All right, so we are just doing our additional section in 9-7, which is law of sines and law of cosines. And so law of sines and law of cosines are for all those triangles that are not right angle triangles. When we have a right angle triangle, we know we can use Pythagorean theorem, which is, of course, a squared plus b squared equals c squared. Unfortunately, many triangles in the world are not perfect little right angle triangles, so we have to have something to help us figure out the measurements of those triangles. So the different angle side combinations that we use for proving triangle congruence, kind of interesting because I'm introducing my IM1 kids to this right now. So one that we had that proved congruence was side, 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 angle, side, 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 angle, and angle, side, angle. Those all did prove congruence, right? The two that didn't prove congruence were angle, 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 because I could have two triangles that have the same degrees, but one is much smaller and one's much larger. They're just similar, they're not congruent. And the other one that didn't work is our donkey triplet, which is ASS or SSA. Neither one of those work, right? Okay, so what we're going to use then for solving those would be law of sines or law of cosines. And it depends on what you're given as to which one of those you're going to use. So law of sines states that the ratio of a side to its angle is the same for all three pairs in a triangle. So you will either see law of sines like this, A over sine A, B over sine B, C over sine C, or you might see that flipped over. I typically write it as sine A, O, and what I do is make the angles capital letters and the lengths lowercase letters. It's just how I've always done it. It's kind of a habit of mine at this point. You can choose which way you'd like to go on that. Okay? So really, the way I think about it is when you are given two angles and a side, okay? So you either have AAS going on because you can figure out the third angle pretty easily by subtracting from 180, or you have ASA. So or you're given two sides and a non-included angle. So you're given side-side angle. What I would say is that it is used when law of sines works really well if you have a set of coordinating angle and its side. So for example, you have angle A and side A, or you have angle B and side B, or you have angle C and side C. Because what it gives you is it gives you a control, basically, that you know the ratio that is supposed to come out to. So now you can just set that equal to the ratio you don't know, but you know that the ratio has to be equal. You can solve for your side or for your angle. Okay, so let's try that on a couple practice problems. Okay, so in example 1, we've got angle B is 25, angle C is 107, and side B is 15. So when I see that, I have a side and an angle that go together. So I know that I've got a ratio of that. The other thing is I can figure out this third angle, right? I can pretty easily do that by subtracting the sum of 107 plus 25 from 180, and that gives me a degree of 48. So this degree I know I can easily figure out is 48. So now that I have law of sines that I can use, I know that I have my ratio, I have my B angle and my B side. So that's going to become my control that I use. So I have sine of 25 over 15, and that's going to equal sine of 48, which I just easily calculated, over A, because A is the side that I'm looking for. Okay. When it says solve a triangle, it means it wants you to solve for all three sides, all three angles. In this case, we're only solving for A. Okay, so when I rewrite that, of course, I can solve any ratio by cross multiplying. So how I set that up is I have A equals the two that are above it and next to it, 15 times sine of 48 divided by sine of 25. Then my calculation after that point is really easy. So you need to be careful on your calculator. Parentheses play a big role here when you're calculating these. So the way I'm going to enter it on my calculator is 15 times the sine of 48. See how it automatically opens up a parentheses? You need to remember to close that. Then I hit equals after that point, just to be sure. Then I divide it by sine of 25 and close the parentheses again. So I get about 26.3, 26.4. Okay, you can round these off. I would say you round lengths to the nearest tenth and angles to the nearest angle. Okay, so the nearest one. Okay, so to me that would be 26.4. Okay. All right, so let's move on to the next one. So we've got example 2. And actually, I'm going to let you try that one on your own. So use number 1 as an example. Come back and check your work with me in a minute. Okay, so let's see if I've got a coordinating pair that I've got a side for A, but I don't have an angle for A, but I do have the other two angles. So that third angle of A is going to be 180 minus 115 and 30 together is 145. So that's going to be a 35-degree angle right in there. Now I've got a coordinating pair. I have side A and angle A, which go together. And in this case, I'm solving for C. So that's the other number I'm going to need to use. So I have sine of 35 over 30 is going to be equal to my sine of 115 over C. Whenever you get this ratio should always be less than 1. If you come up with a ratio that's not less than 1, it's going to be an impossibility because remember it's a ratio. It can't be more than 100%. Makes no sense. And 1 is the decimal equivalent of 100%. Just something to kind of tuck into your memory for future. So C would equal 30 times sine of 115 over sine of 35. So the length of C, and I'm going to do that again on my calculator carefully, 30 times sine of 115, close your parentheses, equals, divided by sine of 35. And that's going to give me about 47.4. Now remember the other thing that we know about triangles is that the largest angle is always directly across from the largest side, the smallest angle is always across from the smaller side, and the middle angle is always across from the middle side. So what I know is that because 115 is much larger than 35, 115 is definitely my biggest angle. It definitely needs to be across from the biggest side, and that biggest side better be more than 30, which 47.4 definitely is. So that is a reasonable answer for that problem. Okay. Sometimes you have ambiguous cases in with law of sines. It always helps that if you don't know, you always draw a picture. So here's some ambiguous cases that could happen. You could have, with an obtuse angle, you could have two possibilities. You could have one triangle formed or no triangles formed. That's possible because that angle is way up here and it's not actually connecting down here and making a triangle. So that's possible. These cases don't happen very often, but just so you can see them. If A is acute, if this angle is acute, there are four possibilities. So you could have one triangle formed. You could have a right triangle formed. You could have no triangle or part of a triangle and then there's a little leg that kind of doesn't attach all the way down. Or you could have two triangles formed, 1 and 2. These are just kind of triangles to be aware of. You'll find that these are going to be some of those situations where you may be given a ratio that's larger than 1, which you know needs to be, that's an impossibility. Okay, so what I would say to you is if you're given just information with no picture, you need to draw that picture, always. Okay, and that ratio has to be less than 1 because it's less than 100%. Okay. All right, so let's see an example through what we've got going on. So we've got two sides and an angle. So we have a triangle given with 120, which has a coordinating side of 22. So I do have a pair that I can use, so I'm good. And then I'm trying to find angle B. So let's see, find the other dimensions. So here we're solving the entire triangle. I would start with my angle B because I know that I've got a side B. So I can set that up. Well, let's see what happens. So I have sine of 120 divided by 22 equals sine of B divided by 15. Okay, so sine of B equals 15 sine of 120 divided by 22. So really when you're shortening up this cross multiplying, you're multiplying the pair that you have, the diagonal pair that you have together, and dividing by the other number. So this ratio that I get here is going to be 15 times sine of 120 divided by 22. Now, here's the interesting thing. This is giving me the ratio. It's not giving me my angle measure. That's definitely not a 0.59 degree angle. That would nearly be a flat line. So it's saying when whatever angle B turns out to be, it has a ratio of about 0.59. So the way that you're going to calculate that in your calculator is now you're going to use your inverse sine. Second sine, 0.59, close your parentheses, and equals, and that's about 36 degrees right there. Okay. So now once you have that figured out, now you can pretty easily figure out the angle of C because it's just 180 minus 120 minus 36, and that gives us an angle of 24. Now we can find our length of C. So we're going to use law of sine again, and we would have sine. I always use my first ratio as my ratio. You could definitely use your B as well, but I always use the given one just to make things easy. Over 22 equals sine of 24 over C. So C would equal 22 sine 24 over sine of 120. And I would have 22 times sine of 24, close parentheses, divided by sine of 120, close parentheses, which gives us about 10.3. Okay. So, and let's go check and make sure that I've got, this is my smallest side, that's my smallest angle. Here's my middle side, middle angle, largest side, largest angle. That ratio always has to be the equivalent, and those proportions always need to go. Small goes with small, medium goes with medium, large goes with large. Okay, good. So law of sines, you can see from the examples we did before, it's pretty easy to use, and it's usable most of the time. However, there are a couple of cases where law of sines is not going to work for us, and that's because we either don't know an angle or we only know one angle. So if that's the case, then now we're going to go to law of sines. So if you have SSS or SAS, you're going to use law of cosines. There is no ambiguity to law of cosines. It works all the time. You could actually use it for the other calculations too. It's just that the law of sine calculation tends to be a little bit easier, so we tend to use that instead. Now, one thing is, if you are solving for a side, your law of cosines are set up like this. I also like to rewrite them and have them solved for the angle as well, because I think you'll make fewer mathematical errors when you do that. And so we can definitely do that. We can go over in class how I came up with these formulas. I'm just moving these around so that my cosine of A, cosine of B, and cosine of C are isolated. So once you do that, cosine of A equals B squared plus C squared minus A squared, all over 2bc. Cosine of b would equal a squared plus c squared minus b squared all over 2ac. And cosine of c equals a squared plus b squared minus c squared over 2ab. So these are exactly the same formulas, just rewritten to isolate the cosine of the given angles. Okay. All right, so let's try one of these. So luckily they've already drawn a picture for us. If the picture is not drawn for you, you are always going to draw a picture. So let's see what we have going on. We've got an A and a C, and we've got angle B. So we definitely have SAS going on. And so I am trying to find side B. So I am going to use this middle formula because B is isolated out here. Even though it's a B squared, we can get the square root of that pretty easily and solve for B. So we're going to use this second one. So my B squared is going to equal, it's basically the two sides that sandwich it. Okay, so A is 11, I'm going to square that, plus 14 squared, minus 2 times those two numbers, 14 and 11, and the cosine of the angle that I have, which is B, which in this case is 34. Okay, now you're just simplifying. Really easy. So B squared is going to equal 121 plus 196 minus 2 times 14 times 11 is 308. And the cosine of 34 is about 0.83. So now just be careful when you're putting this in your calculator, but it's pretty easy. You're just going to do 121 plus 196 minus, and then I put this multiplication in the parentheses together, and I get B squared value of 61.36. So if 61.36 is my B squared, I just need to take the square root of that, and I get B is equivalent to about 7.8. It's about 7.8 over here. Okay. Now here's the great thing. You really only ever have to use law of cosines once in each triangle, because once you've got a pair now set up, now you can go back to using law of sines. So now that I've got my control group, as I like to call it, right? Now I can go back to law of sines. So now I need to solve for A or C. Let's pick one. Let's pick A. So sine of 34 over the 7.8 value we just figured out is equal to sine of A over 11. So sine of A equals 11 times sine of 34 over 7.8. And if I'm careful in the calculator, I can do that. I tend to find it more problematic if I try to do that. So I just find this value and then take the inverse sine of it. So I do 11 times sine of 34, and then I divide it by 7.8, which gives me about 0.7886. So the second sine of 0.7886 is about 52 degrees. So now I've got a 52 degrees in there. Now I can really easily solve for C, because that's going to be 180 minus 52 minus 34, which is going to give me 94 degrees. And again, I can go back and check that my ratios are correct. And so I should have the shortest side, which is my 7.8, goes with my smallest angle, which is 34. My middle side goes with the middle angle. Hypotenuse goes with the largest angle, which it does. So my triangle checks out. Okay. Go ahead and do the one at the bottom, and then come back and check your work. Okay, last one. So now we've got a side-side-side triangle. We have no angles given to us. So we are definitely going to use our rewritten cosine formulas. Just these, again, rewritten so that the cosine is isolated. Do you have to rewrite it? No, I just find it easier because it's already isolating what we need to find. So, and we are trying to find the opposite side B. So they want us to find angle B first. Okay, so I'm going to use this middle calculation. So cosine of B is going to equal my A squared and my C squared. So 12 squared plus 20 squared minus B squared all over 2 times 12 times 20. So once I simplify that, that's definitely calculator work. 12 squared, oh, that should be a squared on there, plus 20 squared minus 27 squared divided by 2 times 12 times 20. You notice I put parentheses in there because if you don't, you're not dividing all of those. You would end up multiplying. So that's negative 0.385. We know from our unit circle if our cosine is negative, we're either working in quadrant 2 or quadrant 3, right? So now I can just do inverse or second function cosine let's go back and do the negative 0.385. And it gives us 112.6 degrees, so let's call that 113. Okay, so C is 113 degrees. Oh, sorry, not C, B. Looked right at it and called it the wrong letter. There we go. Must be late on a Friday again, right? Okay, so now that we did that, now we can go back to using law of sines to find our missing angles, because now we've got a pair. So let's go and solve for C. Why not? So now I've got sine of 113. That's my B angle, and my B side is 27. My sine of my C value I don't know yet, but I know the length is 20. So sine of C equals 20 times sine of 113 divided by 27. So sine of C equals 20 times sine 113 divided by 27 is 0.68, and the inverse sine of 0.68 would be about 43 degrees. So C is about 43. And then we can easily figure out angle A, because angle A is going to equal 180 minus 113 minus 43. So A is going to equal 24 degrees. Again, go back and check your ratios, make sure they make sense. Short side, small angle, middle side, middle angle, long side, big angle. You got it. Law of sines, law of cosines. See you Monday.